Hello everyone, I hope you all are doing well. Welcome back to AWS AI Engineer Essential series. My name is Dheeraj Choudhary and today it's time to dive deeper. Machine learning isn't just one approach, there are three main types and understanding the differences between them is very crucial for you. Let's start with a quick overview of all three types. Think of supervised learning as learning with a teacher who provides the right answers. Unsupervised learning is like learning on your own, discovering patterns without guidance. And reinforcement learning is like learning by trial and error, getting rewards for good decision and penalty for the bad ones, as I explained in the previous video. Now, supervised learning works with labeled data. You give the machine examples with correct answers, and it learns to predict answers for new examples that it has not seen, like a student learning from a teacher. Unsupervised learning works without labels. The machine receives raw data and discovers the hidden patterns, like groupings or structures on its own, like exploring a new place and finding interesting connections. Reinforcement learning is about interaction and rewards. The machine takes action, gets a feedback in the form of rewards or penalties, and learns to maximize rewards over time, like training a dog with treats. Here is the key. Each type solves a different kind of problem. Some problems need labeled answers, some need pattern discovery, and some need learning through interaction. Understanding which type to use when is what makes machine learning powerful for you. Let's dive into supervised learning, the most common and widely used type of machine learning. This is what powers most of the AI application that you use every day. Supervised learning means machine learns from labeled data examples. Every piece of training data comes with the correct answer. You provide input and the right output, and the machine learns from the connection between them. Think of it like a student learning with an answer key. You solve problems, check the answers, and learn from your own mistake. The machine does the same thing. It looks at examples with correct answers and adjusts until it gets better. The algorithm's job is to find patterns between the input and the output. If you show it thousands of house features paired with their prices, it learns what makes a house expensive or cheaper. This discovers the hidden relationship in the data. Once trained, it uses those learned patterns to predict the new unseen data. Show it a house it's never seen before and it can predict the price of that house. That's the power of supervised learning. This is the most common type of machine learning in real world application, from spam detection to medical diagnostic to credit scoring. Most practical AI uses supervised learning currently. Here is a simple analogy. Imagine a teacher showing you flashcards and pictures of fruits and telling you this is apple, this is banana, this is orange. After seeing enough examples with labels, you naturally learn to identify fruits on your own. That's exactly how supervised learning works. Supervised learning has two main branches, and it's important to understand the difference between them because they solve two different problems. Classification is about predicting categories or labels. The output is a discrete choice. Something belongs to one category or another. In this email, spam or not spam, is this image a cat, dog, or bird? These are classification problems. With classification, you are putting data into buckets. Spam or not spam, cat, dog, or bird, good or bad, approved or rejected, the machine learns to assign new examples to right category based on pattern it has discovered. Now, regression is different compared to classification. It's about predicting numeric values. What will this house cost? What will the temperature be tomorrow? How much revenue will we make next quarter? These are regression problems. With regression, the output is continuous number, not a category. So the example that we see over here, so if you try to see what's the difference, this is going to have two categories, yes or no, but it is not going to have going to give you the output in numeric format. For that, you have to use regression. So the output is continuous number, not a category like we have in classification. A house could be of $200, 200K dollars, 350K dollars, or to 425K, any number. The temperature could be 25 degree, 27.5 degree, or 29.3 degrees. The machine learns to predict the exact value while it is going to predict based on the learning that it has done previously. Now here's the key difference. Classification gives you labels, that is discrete choice, yes, no, maybe. Regression gives you numbers, that is continuous value. Just remember this. Classification answers which category, regression answers how much, what's the value. Let's look at a real world example of supervised learning in action. These are systems you probably use every day without realizing they are powered by supervised learning. Email spam filter is a classic example. Gmail, Outlook, and other email services train their filters on thousands of email that are already labeled as spam or legitimate. The algorithm learns patterns, certain words, sender addresses, links that indicate spam. Now it catches spam automatically. Face recognition on your phone uses supervised learning too. The system is trained on millions of labeled photos. This is John, this is Sarah, this is Mike. It learns the unique features of each face, and now it can unlock your phone by recognizing your face. Medical diagnosis is saving lives. Doctor train AI systems on X-rays that are already labeled as healthy or diseased. The algorithm learns to spot the pattern that indicates the diseases. Now radiologists use it to catch cancers and other conditions earlier. Credit scoring uses historical data. Bank trained models on past loans. This person paid back on time. This person defaulted. The algorithm learns which factor predicted default risk. Now it automatically assesses loan application for that specific user. Voice assistants like Siri and Alexa use speech recognition trained on thousands of labeled audio clips. The system learns to recognize words, accent, and speech patterns. That's how it understands what you are saying. Now let's talk about unsupervised learning. It's completely different from supervised learning because there is no teacher here, no labels, no correct answers. The machine has to figure out everything on its own. Unsupervised learning means the machine learns from unlabeled data. There is no correct answers given. You just feed it raw data and the algorithm has to discover what's interesting or meaningful all by itself. The algorithm finds hidden pattern and structures on its own. It looks for similarities, differences, and groupings that human might have not noticed. It's exploring the data without any guidance about what to look for. Think of like exploring a new city without a map. You wander around and naturally you start noticing neighborhoods. Oh, this is the area which has a lots of restaurants. This area has shops. This area is residential. You discovered these patterns yourself, and that is what supervised learning is. This is useful when we don't know what we are looking for. Maybe you have customers' data, but you don't know how to segment them. Unsupervised learning can discover customer groups you never thought of. It helps discover insights human might miss. The algorithm can find patterns in massive datasets that would be impossible for a humans to spot manually. It uncovers relationship structures we didn't even know which existed or not. Here's a simple analogy. Imagine organizing your closet by grouping similar clothes together: shirts with pants, pants with pants, summer clothes versus winter clothes. Nobody told you how to group them. You just naturally saw the similarities and organized them. That's exactly how unsupervised learning is going to work for you. Unsupervised learning has two main types. Understanding the difference between them is crucial because they serve completely different purposes. Now, clustering is about grouping similar data together. The algorithm looks at your data and automatically create groups where similar items end up in the same cluster. It's the most common type of unsupervised learning. A classic example is customer segmentation. You feed the algorithm your customer data, that is like purchase history, browsing behavior, demographics, and it will automatically group similar customers together. Maybe it finds budget shoppers, luxury buyers, and occasional browsers. You didn't tell it these categories, it discovered them by himself. Another example is document organization. If you have thousands of news articles, clustering can automatically group similar articles together, like sports article with sports, politics with politics, technology with technology, all without anyone labeling them at the first place. Dimensionality reduction is the second type, and it is different. It's about simplifying complex data while keeping the important features. When you have data with hundred or thousands of features, in layman term, I would say columns in your CSV file, it's hard to visualize and process. Dimensionality reduction compresses it down for you. For example, compressing images while keeping the important features. An image might have millions of pixels, but dimensionality reduction can represent the same image with fewer numbers while preserving what makes it recognizable. Another use is visualizing high dimensional data in 2D or 3D. If you have a customer data with 50 different features, you can't visualize that. Dimensionality reduction techniques like PCA can compress it down to 2 or 3 dimension so you can actually see the patterns on a chart. Let's look at real world examples of unsupervised learning. These are systems that are discovering insights and patterns without any labeled data to guide them. Customer segmentation is huge for companies like Netflix and Amazon. Netflix doesn't have someone labeling customers as action movie lovers or documentary watchers. Instead, it uses unsupervised learning to group customers by their watching behavior. Netflix discovers these segments automatically and uses them to recommend content. Anomaly detection finds unusual pattern in the data. Credit card companies use this to detect the fraud. They don't manually label transactions as fraudulent or legitimate. Instead, they train on normal transaction and the algorithm learns what's normal looks like. When something unusual happens, like a purchase in a different country, an unusual amount, it flags it as potential fraud. The same technique catches network intrusions. Security teams don't have labels for every type of attack. Instead, they feed the algorithm normal network traffic. It learns what normal looks like, and when something is abnormal, which is happening, it is going to raise an alert for you. Recommendation system powers the customers who bought this also bought that suggestions. So Amazon doesn't manually decide which product to bundle together. It analyzes buying patterns and discovers which products are frequently bought together. So when you select one product, once you go inside that product, automatically it starts giving you recommendations saying that other people who bought this item has clubbed it with below items. This is clustering products by purchasing behavior. Gene sequences is revolutionizing medicine. Researchers have massive amount of DNA data, but they don't know what patterns matter. Unsupervised learning discovers clusters of similar genes and identifies patterns that relate to diseases or the traits. Market basket analysis discovers what products are frequently bought together. Grocery stores use this to understand the shopping behavior, like beer and chips is bought together, milk and bread is bought together, and use these insights for store layout and promotions. No one manually creates this association, the algorithm is going to discover them for us. Now let's talk about the third type, reinforcement learning. It's completely different from both supervised and unsupervised learning. This is how machines learn to play games, control robots, and make sequential decisions. In reinforcement learning, an agent learns by interacting with the environment. The agent takes action, observes what happens, and learns from the feedback. It's not given examples or labels. It learns through experience. The agent gets reward for good actions and penalties for bad actions. Think of it like training a dog. When it sits on command, you give him a treat. When it misbehaves, there is no treat. Over time, the dog learns which behavior is going to get reward. The goal is to maximize total reward over time. It's not just about immediate rewards. Sometimes the agent has to accept short term penalties to achieve a bigger long term reward. The best overall strategy may require some sacrifices also along the way, which this reinforcement learning algorithm finds out. Now, as I gave you one example, it could be like training a dog, giving treats for good behavior. Likewise, There is no labeled data in reinforcement learning. The agent discovers the best strategy through trial and error and experience. It explores different action, sees what works, and gradually learn the optimal policy for you. Here's a perfect analogy. Learning to ride a bicycle, when you first try, you fall. That's a penalty. You adjust your balance. When you stay upright, that feels good, and that's a reward for you. You fall again, adjust more. Through repeated trial and error, getting feedback from every attempt, you eventually master riding the bicycle. That's exactly how reinforcement learning works. To understand how reinforcement learning works, we need to break down its key component. These are five elements work together to enable an agent to learn through trial and error. The agent is the learner and the decision maker. This is the AI that's trying to learn the optimal behavior. In a game, the agent is the AI player. In robotics, the agent is the robot's control system. The agent observes the environment and choose actions. The environment is everything the agent interacts with. It's the world outside the agent that respond to its action. In a video game, the environment is the game world. For a self-driving car, it's the road, traffic, and the pedestrian. The environment presents challenges and opportunities while the algorithm is learning from it. Actions are the choices that agent can make. These are the possible moves available at any moment. In a game, action might be move left, move right, jump, or shoot. For a robot, actions could be move forward, turn, accelerate, or stop. Rewards are the feedback signals. They tell the agent whether its action was good or bad. Winning a game might give plus 10 points. Losing a game might give minus 5 points. So staying alive gives a small positive reward. These rewards guide the learning process for the agent. Through repetitive interactions, the agent learns the optimal policy, the best strategy to maximize the total rewards over time. The policy maps situations to actions. It learns when I am in this state, taking this action gives me the best long term outcome. That's the ultimate goal of reinforcement learning. Reinforcement learning powers some of the most impressive AI systems in the world. Let's look at real world example that shows just how powerful this approach can be. Game AI is the most famous example. AlphaGo, developed by DeepMind, used reinforcement learning to beat the world champion at Go, a game with more possible position than atoms in the universe. It didn't memorize moves, it learned strategy through playing millions of games against itself. Chess engines and AI that masters Atari games use the same approach. Robotics is where reinforcement learning truly shines. Robots use it to learn physical skills, how to walk without falling, how to pick up objects without dropping them, how to navigate around obstacles. Instead of programming every moment, we let robot learn through trial and error, getting rewards for success and penalties for the failure. Self-driving cars are learning optimal driving decision in real-time traffic. The car is the agent, the road is the environment. Action include acceleration, braking, and turning. Rewards come from safe driving, reaching destination, and avoiding collision. The car learns strategy to navigate complex traffic situations. Trading algorithm use reinforcement learning to develop buy and sell strategies in the stock market. The agent learns which pattern signals good entry and exit points. It gets rewarded for profitable trades and penalized for the losses. Over millions of simulation, it discovers strategies that maximize returns. Personalized recommendations on YouTube and TikTok optimize video suggestions for your engagement. The agent chooses which video to recommend to you. The reward is whether you watch it, how long you watch, whether you like it or not. The algorithm learns your preferences and discovers what videos keep you engaged the longest. And now let's bring everything together and compare all three types of machine learning. Understanding how they differ will help you know which one is to use for different problems. First, look at the data. Supervised learning needs labeled data. Every example comes with correct answers. Unsupervised learning works with unlabeled data. no one tells the algorithm what to look for. And reinforcement learning has no data set. It is going to learn by doing it. Now, the goal is different for each type. Supervised learning goal is to predict outcome for new inputs. Unsupervised learning goal is to find hidden patterns and structured in the data. Reinforcement learning goal is to maximize rewards and learn the best strategy. How they get feedback differs too. Supervised learning gets immediate feedback. Here is the right answer, where we provide the correct answers to them while training. Unsupervised learning gets no feedback, it just discovers pattern on its own. Reinforcement learning gets delayed feedback, rewards or penalties based on overall performance over time. Now, spam detection is supervised learning because emails are labeled spam or legitimate. Customer grouping is unsupervised learning because there are no labels, just customer data to cluster. Then game playing AI is reinforcement learning because it learns by playing and getting rewards for wins. And here is the key takeaway. Choose supervised learning when you have labeled data and want predictions. Choose unsupervised learning when you have unlabeled data and want to discover patterns. Choose reinforcement learning when you want an agent to learn optimal behavior through interaction and rewards. So when should you actually use each type? Let's break down the decision making process so you know which approach to pick for different problems. Use supervised learning when you have labeled historic data. You need examples with correct answers. Past emails labeled as spam, past images labeled with what is there in that image, past customers labeled as churned or retained. If you have this data and you know what you want to predict, supervised learning is your answer. A practical example is predicting customer churn. You have historic data showing which customers stayed and which left. You predict which current customers are likely to leave. Or classifying images, you have labeled training images so you can classify the new images accurately. Then comes the unsupervised learning when you have data but no labels. You don't know what pattern exists or how to organize the data. Then you want to use the algorithm to discover structure on its own. You are not exploring, not predicting specific outcomes. Example include finding customer segments. You don't know what segments exist, but you want to discover them. Or detecting anomalies in network traffic. You don't label every intrusion manually. You let the algorithm learn normal behavior and flag what's unusual for you. Then comes reinforcement learning when an agent needs to make sequential decisions over time. When the goal is long term optimization, not immediate prediction, when the agent learns through trial and error and interaction with an environment. Examples are game AI. The agent makes moves sequentially to win over time. Robotics, the robot take actions to learn skills. An autonomous system like self-driving cars or trading algorithms that make decision continues to optimize long-term output. That wraps today's tutorial. We have covered all three types of machine learning in depth: supervised, unsupervised, and reinforcement learning. If you enjoyed this video and want to keep learning step by step, make sure to like the video, subscribe to my channel, and hit the bell icon so you don't miss the upcoming tutorials. Thanks for watching, and I will see you in the next video.